Chapter 3 Polynomials. Dear student, consider each term of the expression p raised to 3 minus 1 upon 2 p square plus p. Here the powers of p are 3, 2, 1 respectively. In an algebraic expression, if the powers of the variables are whole numbers, then that algebraic expression is known as polynomial. For example, 16 is also a polynomial. It is called as constant polynomial because it is a constant number. So 0 is also a constant polynomial. But in this example, root y plus 5 is not a polynomial because root y plus 5 means y raised to 1 upon 2 plus 5, and here power of y is 1 upon 2, which is not a whole number. Now these are the types of polynomials based on number of terms. If the polynomial contains only one term, then it is monomial. For example, 2x, 6. If the polynomial contains two terms, then it is a binomial. For example, x square plus 1. If the polynomial contains three terms, it is trinomial. For example, x square minus 3x plus 4. The polynomials are written as px, qy, rm according to the variable used. Now, degree of a polynomial in one variable. In case of a polynomial in one variable, the highest power of the variable is called the degree of the polynomial. The degree of any non-zero constant polynomial is 0, and degree of zero polynomial is not defined. Now state whether the given algebraic expressions are polynomials. Justify. Y plus 1 upon y. It's not a polynomial because 1 upon y means y raised to minus 1. That means the power is a negative number. Next, x square plus 7x plus 9. It is a polynomial as the power of the variable x is 2 and 1 respectively. Both are positive whole numbers. Next question. Write the degree of the given polynomials. Root 5. Degree 0. X raised to 0. Degree 0. Root 2 m raised to 10 minus 7. Degree 10. 7y minus y raised to 3 plus y raised to 5. The highest power is 5, so degree 5. Next, m raised to 3 n raised to 7 minus 3 m raised to 5 n plus mn. Here the polynomial is having more than one variable. There are two variables m and n. So the rule is like this: the highest sum of the powers of the variables in each term of the polynomial is the degree of the polynomial. Here, in first term, the sum of the powers is 3 plus 7, that is 10. In second term, the sum of the powers is 5 plus 1, that is 6. And in the third term, the sum of the powers is 1 plus 1, that is 2. So, the highest sum of the powers is 10, and therefore the degree is 10. Now we can have different types of polynomials based on degree. For the polynomial in one variable, if the degree is 1, it is called as linear polynomial, and the standard form is ax plus b. Here a and b are the coefficients and a is not equal to 0. Secondly, if the degree is 2, it is quadratic polynomial, and the standard form is ax square plus bx plus c. Here a, b, c are the coefficients and a is not equal to 0. If the degree of polynomial is 3, it is called cubic polynomial and its standard form is ax raised to 3 plus bx square plus cx plus d. Here a, b, c, d are the coefficients and a is not equal to 0. And polynomial a n x raised to n plus a n minus 1 x raised to n minus 1 plus dot 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 plus a 2 x raised to 2 plus a1x plus a0 is a polynomial in x with degree n, and an minus 1 dot 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 a2 a1 a0 are the coefficients and an is not equal to 0. Then standard form, coefficient form and index form of a polynomial. Px is equal to x minus 3x square plus 5 plus x raised to 4 is a polynomial in x which can be written in descending powers of its variable as x raised to 4 minus 3x square plus x plus 5. This is called the standard form of the polynomial. But in this polynomial, there is no term having power 3 of the variable. We can write it as 0x raised to 3. It can be added to the polynomial and it can be rewritten as x raised to 4 plus 0x raised to 3 minus 3x square plus x plus 5. And this form of the polynomial is called index form of the polynomial. One can write the coefficients of the variables by considering all the missing terms in the standard form of the polynomial. So 1, 0, minus 3, 1, 5 is the form of polynomial which is known as coefficient form. The question is, classify the following polynomials as linear, quadratic and cubic polynomial. 2x square plus 3x plus 1, it is quadratic polynomial. 5p, it is linear polynomial. Root 2y minus 1 upon 2, it is linear polynomial. M raised to 3 plus 7m square plus 5 upon 2 m is cubic polynomial. Now question, write the following polynomials in standard form. M raised to 3 plus 3 plus 5m is equal to m raised to 3 plus 5m plus 3. Next one, minus 7y plus y raised to 5 plus 3y raised to 3 minus 1 upon 2 plus 2y raised to 4 minus y square. The standard form, y raised to 5 plus 2y raised to 4 plus 3y raised to 3 minus y square minus 7y minus 1 upon 2. The question is, write the following polynomials in coefficient form. X raised to 3 minus 2 is equal to x raised to 3 plus 0x raised to 2 plus 0x minus 2. So the coefficient form is equal to 1, 0, 0 minus 2. Next one, 5y. 5y is equal to 5y plus 0. So coefficient form is 5, 0. Next, 2m raised to 4 minus 3m square plus 7. So 2m raised to 4 minus 3m square plus 7 is equal to 2m raised to 4 plus 0m raised to 3 minus 3m raised to 2 plus 0m plus 7. So coefficient form 2, 0, minus 3, 0, 7. Next is minus 2 upon 3. The coefficient form into bracket minus 2 upon 3. Next question, write the polynomials in index form. Use the variable x. 1, 2, 13. the index form x raised to 2 plus 2x plus 13. Next one, 5, 0, 0, 0, minus 1. The polynomial in index form 5x raised to 4 plus 0x raised to 3 plus 0x square plus 0x minus 1, that is equal to 5x raised to 4 minus 1. Now let's see